Now, we're actually going to cover working with R3D files and the additional steps and concerns that they raise. There are a few things to break down here, and we're going to start with the decode. Note that this is a working intro to the R3D format. We don't deep dive into the tech here, as our aim is to deliver the current project. There will be more advanced tech later in this course. So, RED cameras encode raw data into R3D files. That data can then be decoded through a number of different settings to produce a starting point for our grade. We can find these settings in a few places. Firstly, we can click the gear in the bottom right. We can then navigate to the Camera Raw tab. By default, this starts with the decode settings for ARRI RAW. We need to use this drop-down menu to select RED. We now have a number of settings to choose from. Please note that this is a decode for an older RED camera. It is not the ideal decode for a recent build using IPP2. We'll start with bit depth and we'll go over decode quality later on. Bit depth selects the bit depth for the footage we're working with, how many colours we have to work with. The higher the bit depth, the more accurate our secondary qualifications will be, in layman's terms. We covered bit depth in a previous lecture, so generally speaking higher is better, though on machines with a lesser spec it might start to slow things down a little bit. The time code must be set before we bring any R3D media into the media pool. In most cases, leaving this on camera is fine. The second option is absolute. This uses a time of day time code using the 24-hour clock. The time code that rises from this depends on the time of day that footage was actually shot. And the edge option makes every single clip start at 1 hour, then count forwards from that point. In most cases, absolute is of more use to us. And finally, we have decode using. This gives us a few different ways to decode our footage. It has the RED default and RED camera metadata settings. RED default may not be applicable depending on the camera settings used during the shoot. Camera metadata uses the camera settings on the time of the shoot to decode the footage. Now this sounds like it might be useful, but I've often found that it doesn't really help. I always find that manually setting up a proper log decode yields the best results. We're going to choose decode using project. This allows us to set our decode settings manually, and we're going to go through the relevant options one by one. So first, color science. We're going to set this to version 2, which is appropriate for our older RED Scarlet camera. Original is the best fit for much older cameras like the first few runs of the RED 1, and IPP2 is the best choice for newer cameras which are using the IPP2 pipeline. So we're going to choose version 2 for this project. Color space. Now there's no hard and fast rule here. You can eventually manhandle any choice in this list into the right place for your project. That being said, we should always try and give ourselves the best starting points. I'm not going to summarize every possible choice here. For now we're going to choose Red Color 3. This is going to help us out a bit with our skin tones and give us a great starting point with our Red Scarlet shot footage. The next setting is Gamma Curve. This has a much larger visible impact on our decode. When choosing our gamma curve, we typically make that choice based on a few parameters. First is the amount of time we're going to spend on our grade. Are we going to go full on and grade in fine detail? In that case, something like red log or red log film is a good choice. These choices mimic what is known as the Cineon curve. More on that in a later module. But basically they provide us with the widest latitude whilst grading. Other choices like red gamma are more geared towards providing a decent image that only needs a few tweaks. Now we're going to go in and grade in detail here, so we're going to choose red log for our gamma curve. So all the other options for now don't matter. The last setting we're going to cover is decode quality. RED files are recorded through a technique known as a Bayer pattern filter. This kind of misses some pixels out when recording. The machine we're working on then uses an algorithm to fill that missing data back in and gives us the best quality image. This is referred to as debayering. When looking through these options, we see that we can choose our resolution and a good or a premium decode. Good does not debayer our footage, it does not fill in the missing pixels. The visible result of this is that we see a kind of blocky noise on our image. This is the fastest choice. Using good quality decodes will make it easier to work on the actual grade. We can then set our machine to render out with the premium quality debayer at the end of the project. Now you need to experiment with these settings and see the impact that it has on the performance of your workstation. If you're using a laptop or a MacBook, start with half res good and move down to quarter res good if that's too slow. If you have a desktop workstation with a decent GPU, let's say GTX 1070 or better, then try half-res premium. You can always take it down a notch if you lose performance. Don't forget about the render cache when working on this project. 1/8 and 1/16 res make important details unintelligible, so caching is preferable to using those settings. Now, this has been a good, if somewhat basic overview of R3D and Resolve. We're now ready to get to work. Click on through to the next lecture when you're ready.